We're actually running like 2 minutes ahead of schedule. Hard to believe. Shall we forge on? Okay. Our next talk is coming from the Naval Research Lab, and it is Benjamin Kirkup speaking about example of built environment microbiome studies.
Hello. So I'm here from the Naval Research Labs, and my disclaimer is basically that if the generals and admirals understood what I was about to say, they probably wouldn't care. And that's actually sort of important in this talk because I'm really interested in what the DoD is doing with the built environment microbiome and why they're doing not more, not less, what they're doing, and how to encourage them to get involved in this area. Because, as we know, they could bring some R&D dollars at least to the table. And so my time as a military scientist has taught me a few things. And one is this risk assessment matrix. It may seem pretty simple to most of us. What you wouldn't know is that privates snuffy on up, they see it basically every day, sometimes as little as every week. A risk assessment matrix like this is used to plan a landing. It's used to plan a daily patrol. It's used to plan the annual and semi-annual PT tests, and it's used to plan the O-Day barbecue. and they are expected to assess what kinds of risks might be involved in burning yourself at the barbecue or getting ambushed on patrol, and to rack and stack and rank, and then take those ones that seem severe up to the boss, ask for what you need, come back, mitigate, reduce that risk until finally the risk is commensurate with the mission. And then you move forward. And if the risk is somehow minor in there, you're supposed to ignore it. And unfortunately, this leads us to prioritize first-order effects. And so if you've got a Koch's postulate organism out there that's, this organism, this person, he goes down, mission's at risk, okay, we get that. We'll mitigate as much as we have to. Second-order effects, well, those start to get hazy because they occur less frequently. They are less clear and less direct. Third-order effects, like that microbe and this guy, he was out drinking, his microbiome, I don't know what's going to happen. Well, okay, that gets put to the end of the line, right? And mitigation that requires research and material commitments and policy, those are big deals. So they're not going to really get us where we want to go. And we all here like the built environment microbiome a lot, sure. But when we look at evidence that people in the military will accept as connecting something to risk, it's going to be stuff that's high on that chart. It's going to be electronically searchable chart review data that's come from clinicians and clinics, and these were severe health threats, right? With big effect sizes, high priorities. And unfortunately, the things that, where we were talking about the wonderful stuff of if it's even questionable that it was a complainer, right? It may impact a lot of people. It may impact their performance in aggregate to a large extent, but it's going to be very diffuse evidence. It's not going to be first-order effects, and it's not going to get the sort of priority that we'd like to see, even if, overall, it could really change the logistical tail, say, of the military. So this really is where I see attention that needs to be paid. We need to figure out how to get data about that non-specific threats in the built environment done to a degree that it is strong evidence for performance impacts and health impacts. Now, that's sort of my takeaway. But if I want to go into what the military is already doing in the built environment, I have a few places where they're already putting some research money. Now, of course, Paula knows this very well. A lot of it has to do with the built environment as a target. And these are high-profile threats. And here, the real reason that people were interested in the built environment microbiome is that it's so messy, it makes it hard to detect even the really dangerous things that you're looking for. And really, when you talk to military folks, DITRA and I won't go into all of the acronyms, but hardening starts with human behavior in the individual. They're going to start with masks. Check your seal. Don't have a beard, right? Those are things that they can hit that are a lot less messy than the built environment microbiome. Detection starts with threat characterization. It starts with the big, what is this box, right? We saw that already. And people at Edgewood Chemical Biological Center are really leading the way in my mind because they're barcoding some of these simulated pathogens and putting them out in the environment and seeing if they can detect them. And incidentally, they happen to be doing built environment work. Well, that's really nice. I like that. But if we want to get past that, we're really going to have to get into demonstrating that the built environment microbiome has a strong role in preventing that threat, maybe a stronger role than the gas mask. And that's going to be hard sell. The next area, this is near and dear to my heart, is wound infections. Now, Acinetobacter really came to the military's attention because A, they didn't know what it was, and B, it hit the front page of the Washington Post. And it was called Iraqibacter. And now, here I'm going out on a limb and highlighting research that's done by the Brits. Jack isn't in the room, so he's missed this. But we have a built environment study here where they demonstrated that Acinetobacter was basically the majority of the bacterial flora on the floor of the hospital. Well, what does that say to all those people who spent their time swabbing Humvees looking for Acinetobacter? Well, A, it says that swabbing wasn't very good. And B, it says that they were looking for a genus. They weren't looking for the problem. Here, the Brits had a problem. They had dozens and dozens of cases over a 9-year period that were killing people in the Queen Elizabeth Hospital, where they treat all of their patients that were coming back from the war zone. And they traced it back to a patient 0 who came from the war zone. Anyway, what they did was they did whole genome sequencing. And they were able to get down to SNP level detection and say, it's not the hospital, it's not a cleaning lady, it was that bed and that scope. Okay, once again though, we're not at the building microbiome. We're at fomites. Everybody gets fomites. Everybody gets that if you have a massively contaminated bed, it's going to cause trouble. And so they were able to really trace genotypes, look at mutation patterns and all of that. But for our purposes, what this will convince the military to do is do better characterization of isolates from clinics and clean some of the beds and get rid of some of the scopes, right? Now, it's an important study, though. I don't want to dismiss it, but it doesn't quite get us where we want to be. Okay, so this is more good news. This is actually that the NRL and the Dahlgren B-20 crew, which do chemical biological defense on ships, are going to be signing an MOU in probably a couple weeks. It's with the lawyers to do the built environment microbiome of ships. And that's because everybody sees acute GI illness attacks on ships. And we've convinced people that even though the buildings themselves have so much influx from the fungi, from the outside air and all of that, you put a bunch of people on a ship, they tend to mutually reinforce. And so this is sort of in ISS land, more related to the NASA space. But I think for this particular set of arguments, we can still talk about the built environment and make some progress. And our materials are very standard, our paints are very standard. There's a good reason to be doing this. And so I think we'll be putting some good money into this. At the same time, rates have gone down. And that's because people have paid attention to sanitation. If there starts to be a GI issue, well, A, that's reportable to HM1, which would be the ship medic, and B, they'll immediately stop self-service at the food line. So once again, we're trying to get back to first-order effects. If we have to pay attention to second, third, and fourth-order effects, we will, but only if it's going to be catastrophic otherwise. Now, here's another problem area that I mentioned very briefly earlier. This is actually under the deck of a UH-60 utility helicopter. Now, what you don't see is that there was actually mold, black mold, toxocladosporium, there we go, all over the top of this. And then under the decks, where the water and the hydraulic fluid and stuff pool, there was all sorts of stuff growing. And yeah, I did sequencing, and I won't bother to show that here. The real problem is that this prompts cleaning efforts. And the cleaning efforts started with bleach, because that's what the sailors trusted. And that immediately ate off the polyurethane and corroded the aluminum and caused the helicopter to go to depot maintenance and require, and then the story gets worse, because they did the depot maintenance, they put the helicopter in storage, and it got moldy in storage, and it went back to depot maintenance. But this is an area where CERTUP has put out a recent statement of need. And CERTUP is DOD, EPA, and DOE. So all three organizations have come together to deal with the fact that our helicopters are moldy. And not just our helicopters, but also the cockpits of the fighters. And that has to do with polyurethane, basically, that gets moldy. And how we're going to treat this in the long run, I'm not sure. But they've come out with some new cleaners that are less corrosive than the bleach. They're going to try putting new agents in the polyurethanes. And we're going to push for them to start monitoring the respiratory condition of crews and maintenance crews, because we want people to be healthy. But this is pretty much a first-order effect for a building microbiome. And so this is really my conclusion. I'd like to reinforce that health data is going to be what drives this. And one man's jack is another man's meta-jack. We need to get good health data, and that probably means monitoring people continuously, probably through either wearables or sensors in their environment that can monitor physiology and so on. And NASA can advise us on some of this. And that it's only secondarily that all the stuff that we usually worry about, like uncertainty about identifying the microbes that we pull up, that just creates a cloud of uncertainty around everything and pushes all of our effects into second and third order land and makes it hard for us to argue for what we're really trying to get done. Thanks.
Well, we should take all the speakers.
Yeah. We haven't been applauding, but perhaps we should. Questions to the Navy? Yeah, I know as an academic, I don't think this first order, second order kind of stuff at all. It's an interesting perspective. Yeah.
So you think this getting into the phylogeny distracts from?
I don't say that getting into it distracts. I'm saying that the fact that it's a muddle at the moment makes it harder to draw clear lines between this problem,
Right.
this result.
Right.
Until we clear that up, it's difficult to make clear cases to the leadership for what things need to be dealt with or even researched.